All right, let's find these, do this graphical analysis here. It says find the domain. Well, the domain, if you do your vertical line scan, it's going to touch everywhere except this line right here and this line right here. Can you see that there's asymptotes there? So every x value will be represented on the graph except this x value at -2 and this x value, which looks like at +3. So in interval notation we write negative infinity to -2 union -2 to 3 union 3 to infinity. So that includes everything but -2 and -3, because see how these brackets mean that those aren't included. The parentheses brackets means they're not included. Okay? To find the range, same deal, but now we're going horizontally. I'm looking down here. Am I ever going to not touch the graph? Ever?
No.
Is there ever a value, a y value, that will not have a representation or a point sitting on it?
Yeah, right.
There is, right here. There is a horizontal asymptote, and that horizontal asymptote is at 0. So the range is going to be from -infinity to 0, union from 0 to +infinity. That's like saying everything but 0. Good?
Yep.
Next, where is it increasing? Well, increasing means from left to right it's getting bigger. And you see how if I jump on the graph from left to right, it's getting bigger?
Yes.
So it's increasing from -infinity to -2, and it's increasing from -2 to, it looks like, well, it's probably right in the middle of that. So this is 3 and this is -2. So what's right in between 3 and -2? So -2 plus 3 over 2, it's 1/2, right? So this point is probably at 1/2. The x value is probably 1/2. So it's increasing also from, we'll put union in here. It's increasing from -2. Notice that's not including -2, okay, right? Because it's actually not defined at -2, right? Because that's not part of the domain up here. So it's increasing from -2 to +1/2 on that interval. On this interval right here, it's increasing. From here to here, it's increasing, because when I go from left to right, the y values are getting bigger. And then it's not increasing anywhere else. So those are the two values where it's increasing. Now it's decreasing. You can probably tell where I'm going with this. It's decreasing from that same point to the right. It's decreasing there. So from 1/2 to 3, it's decreasing. And then it's decreasing again from 3, again, not including 3, but just to the right of 3, which there is no exact point. It's just, it's an infinite number of numbers going up that. But just to the right of 3, all the way to infinity, it's decreasing.
Okay.
Because the values are getting smaller from left to right. If I jump on here and I go to the right, I go this way. If I'm looking at my points on a graphing calculator, you'll see the y values getting smaller as you go further to the right. So that's what that means. All right, what's the maximum and what's the minimum? The maximum is going to be, well, there is really no maximum, but there's a relative maximum. The relative maximum is going to be that point right there.
It should be 0.
So it's at 1/2. Remember we talked about it being at 1/2. It's kind of hard to tell what it is.
Looks like it's below 0.
It looks like it's below 0, to be honest with you. So this is again where this isn't an exact science. We don't know really, because they didn't give us an equation. So we can just estimate, let's say -1/4. I'm just giving an estimate. And the minimum value, there is no minimum value, because none of these values, they get closer to 0 left and right, and these things go down, there is no relative min or max, so you can say none. And continuity, is it continuous? No. If that's a yes or no question, I think you say no. Is it symmetric? It is symmetric over the line, over this line right here. So it's symmetric over the line x equals 1/2. It's concave. Let's see. So for concavity, intuitively speaking, it's concave up there. And I think that's really, the definition of concavity is probably going to come along when you get into calculus more, but this is just the intuitive definition, I think. So it's concave up from negative infinity to -2, and also from 3, that section is also concave up from 3 to infinity. That's where it's concave up. And it's concave down between -2 and +3, because it's shaped down like that. X-intercepts, there are none. Y-intercept, we're not really sure, but we're going to take a guess, maybe -1/2. Again, we don't know exactly because the y-intercept is somewhere right here. We just don't know what it is exactly, because we're not given an equation, so huge estimating is probably fine. And end behavior, both to the right and to the left, y is going to 0. And that, by the way, is the definition of a horizontal asymptote. The end behavior is to a value not infinity. That's what an asymptote, a horizontal asymptote, would look like.